digital readout shows the tolerance level is slightly high on this butterfly valve.
The fat content is holding steady at 39.5%.
Good, keep the flow rate.
The pressure on line 3 looks slightly high. Yes, I noted that. The flow rate is consistent.
Celsius.
All parameters are within tolerance. The cycle is proceeding as expected.
The flow rate on Unit 3 is stabilizing now.
Good. Keep monitoring the thermal regulators closely.
Gauge reading is stable. Log that, please.
Confirmed. All parameters are within tolerance.
pH is holding steady at 6.8,
And the fat content.
35%. We are clear to proceed.
Here, the differential pressure is slightly elevated. Yes, but it's still within the acceptable range for this phase. Pressure looks good here. Yes, and the temperature differential is exactly where it should be in the hot zone.
The RTD seems stable at 22 degrees Celsius. Okay, confirmed on the reference. Logging the data point now. Okay, the regeneration section is showing a clear gradient, but that hot spot near the valve indicates a potential bypass issue.
We are holding steady at 85% recovery. Excellent. The new plates are performing well.
Pressure-reducing valves ensure a stable and efficient steam supply, critical for effective energy management in the pasteurization process.
We need to increase the flow rate to 550 liters per hour.
Okay, I've logged the adjustment. The holding time is the thermal gradient here seems slightly high.
Yes. Look at the reading on the exchanger itself.
The glycol cooling system is essential, maintaining a precise 5 to 7 degrees Celsius.
Check the pressure on line 3. It should be stable before we start the transfer.
Confirm the gauge is holding steady. We are good to go.
Check the glycol pressure on loop 3. It's reading slightly high according to the log. All right, I'll throttle the main valve here and monitor the flow rate.
pH levels look good on batch 34B.
And the fat analysis confirms the target range. We are clear for
Look at the inversion starting right there.
That's
Look at there.
Yes, the granules are perfectly within the 3 to 5 millimeter range.
Check the viscosity reading on panel B.
It's slightly high, but within tolerance.
Adjust valve 4 just
Check the uniformity on this batch. The buttermilk is draining well. Looks good. We are ready for the washing stage.
The grains look good, ready for the second wash.
initiating cycle 2 now.
Ensure the flow rate to tank 4 is stabilized.
I've adjusted the valve junction. It's holding steady now.
We are ready for transfer. Start the pumps.
Pumps engaged. Flow looks good.
Confirmed. Receiving.
The grainy structure is clearly visible here at the discharge. It's close, but the moisture sheen shows it still requires further work.
Levels are stable across all bearings.
Confirmed. The LEDs are showing green.
The current is stable at 40 amps.
Vibration levels look good after the adjustment.
Visual confirmation on the wash cycle. Everything looks clean. All right, let's start the discharge sequence.
Here in the working and kneading hall, the continuous butter machines transform the grains
The multi-stage process begins with loose grains, which are then expertly kneaded and compressed, resulting in the smooth texture you see here.
The dosing system is holding steady at 1.5%.
Good, the samples look consistent with the target range.
How is the consistency looking on this batch?
It's fully incorporated now, ready for transfer.
The microstructure verification confirms proper salt mixing.
Is exactly what we aimed for.
The internal temperature is holding steady at 18.5 Celsius.
The jacket coolant is stable. Consistency looks good.
The consistency looks perfect today. We are cleared for packaging.
Look at the spreadability index. We're slightly high on firmness.
Agreed. Did you review the latest portion weights?
Yes, they are all within tolerance. I'll log it now.
The flexible forming system allows us to simultaneously produce diverse product sizes, from small
Temperature check on line 3.
Holding steady at 5 degrees Celsius looks good.
See the spike on the left side there?
Yes, increasing the coolant pressure now. It's coming down. Check the alignment on line 3. Looks good from here, steady flow.
We need to increase the speed on the unsalted line.
The sensor is clear, pushing the next batch now.
Vision systems scan for incomplete wrapping, torn wrappers, or misaligned graphics, ensuring professional automated quality verification.
We verify the best by dates against the production codes to maintain full traceability.
To ensure food safety, butter samples are meticulously diluted and plated on selective media before incubation.
Look at the reading, 75.2. It aligns perfectly with the standard.
Confirmed. The color consistency is approved for this batch.
Okay, lot number 743. Confirmed. Scanning now.
Utilizing our quality management system, we ensure that every certificate of analysis provides full traceability for the customer.
Check the metrics on the south quadrant. We have a slight variance.
Confirmed. The system is adjusting automatically.
Watch the clearance on the left.
Okay, got it. Move the jack clear of bay 3.
Please pick 6 units from slot 34B.
6 picked. Confirming order 205.
Pull it tight on your side. Ratcheting it down now. Looks secure. Let's prep for the next one.
The date code matches the manifest.
Okay, applying the QA sticker now.
Strap secured on the front pallets. Confirmed on the manifest. Seal is ready.
All right, clear to close. There's a hairline fracture right here on the casing.
Confirmed. Entering as physical damage.
The ATP bioluminescence test confirms the efficacy of the sanitation process, ensuring critical food safety standards are met.